In this video, we're going to talk about solving linear inequalities. Now, to solve an inequality that involves one variable means to find all values of the variable that make the inequality true. So let's look at some examples. Let's solve these inequalities and then graph their solution on a number line. Part A says 3x minus 5 is less than 6 minus 2x. Now again, what we want to do is find all values of x that make this true. Now some values of x will make it true and other values of x will make it not true. For example, 0. If you plug in 0 for x, the left hand side would be minus 5, the right hand side would be 6, and minus 5 is less than 6, so 0 is a solution. If you plug in, for example, 10, you will not have a solution because the left hand side would be 25 and the right hand side would be negative 14, and 25 is not less than negative 14. So 0 is a solution, 10 is not a solution. How do we find all solutions? Well, we solve this in a similar way that we do when we're solving equations, and we're going to use this principle that we had in the last video that said that if A is less than B, then A plus C is less than B plus C. Okay, what we're going to do is, first of all, gather all of our x's on one side of the equation. I'm going to add 2x to both sides. Now, why is it okay to add 2x to both sides? Well, by this principle that we just looked at. We're thinking of the A as being 3x minus 5, and the B as being 6 minus 2x. The C that we're adding to both sides is 2x. Okay, so if A is less than B, then A plus C will be less than B plus C. So what is A plus C? Well, that will be 5x minus 5. And the right-hand side will just be 6. Okay, now let's gather all of our constants onto the right-hand side. Let's add 5 to both sides. Now again, why is it okay to add 5 to both sides? Well, we're using this principle again. We're thinking of the A this time as being 5x minus 5 and the B as being 6. And our C that we're adding to both sides is 5. And what we get is 5x is less than 11. Now, in this type of situation, you might think, oh, okay, the next step is to just divide by 5. Well, remember, for our principle that we had in the previous video said that if A is less than B and C is greater than 0, then AC is less than BC. So if you multiply both sides of an inequality by a constant, then you'll still get a true inequality. By a positive constant, you'll still get a true inequality. Now, we didn't say anything about dividing by a constant, but actually dividing by 5 is the same thing as multiplying by 1/5. So we could think of the A this time as being the 5x, the B is being 11, and the C that we're multiplying both sides by is 1/5. And notice 1/5 is a positive number. So what we get on the left side is x, on the right side is 11/5, and we don't have to flip the inequality because we're multiplying both sides by a positive number. So x is less than 11/5. Now 11/5 as a decimal is 2.2. It's 2 and 1/5. So this is the solution of our inequality. Any value of x that's less than 2.2 will make this inequality be true, and any x that's greater than 2.2 or equal to 2.2 will make it not true. And remember, 0 was a solution, wasn't it? And notice 0 is less than 2.2. 10 was not a solution, and 10 is not less than 2.2. Okay, if we're going to graph this solution on a number line, what that means is to shade in all the points on our number line that make this inequality true. And on our number line we have 0, 1, 2, 3, etc. You also have minus 1. Now 2.2 is somewhere on here. It is maybe about right here. That's 2.2. We're going to shade in all the numbers that are less than 2.2. And now 2.2 itself is not a solution, so I'm going to put a little bit of a rounded line here. It would be more like a bracket if we had an or equal to here, if 2.2 itself were a solution. And we're going to shade in everything to the left of 2.2. And I make an arrow indicating this goes all the way out to infinity off to the left. Okay, now let's solve another inequality. This says that 13 minus 7p is greater than or equal to 10p minus 21. Now again, let's gather all the variables on one side, gather our like terms together, and gather all the constants on the other side. Now one way to do this would be to add 7p to both sides, and the p's would be on the right hand side of the inequality. But I don't want to do that right now because I want to illustrate something. Let's subtract 10p from both sides. The left-hand side would be 13 minus 17p is greater than or equal to minus 21. Now, subtracting, why can we subtract? Well, remember, we had something that said if a is less than b, then a plus c is less than b plus c. Why is it okay to subtract? Well, subtracting is just like adding a negative number. So subtracting 10p is like adding a negative 10p. So you can subtract the same thing from both sides. Now, again, let's subtract 13 from both sides. And what we end up with is negative 17p is greater than or equal to negative 34. And of course, the next step would be to divide by negative 17, or which is really like multiplying by negative 1/17. And notice that we are multiplying both sides by a negative number. Now, so the inequality is going to flip here. Instead of having a greater than or equal to, we will have a less than or equal to. Now, the negative and negative will cancel. The 17 and 1/17 cancel. We're just left with p on the left side, and 34 over 17 is 2. The negatives cancel here. So we have p is less than or equal to 2, but I want you to be real careful here to flip that inequality. It's not p is greater than 2, it's p is less than or equal to 2. And again, I'm just going to write the number 2 on the number line. Okay, there's also other numbers on the number line. But we're shading all the values of x that are to the left of 2. Now, since it's including 2 itself as a solution, I'm going to make it more like a bracket here. Okay, and then we're going to shade in everything to the left. Okay, that's not very good, but shade in everything to the left.